That's for cohort 11. Our break is starting on Saturday. Yes, so this is going to be an opportunity for us to cover up things we missed, and then we start learning our Python so that when we start, I was looking at our timetable the other day, and I noticed that it's still the same thing as C. Every day you are learning new concepts, and most of us are working or in school, and with that, you don't have the time to spend a whole day to study a particular concept and then also attempt all the tasks that day. You understand? So it's always good we are ahead so that, let's say today we maybe from now we do data types and variables, so that when the tax comes on data types and variables, we already have an idea on what we are going to do. So that's what we are going to do next, begin our break. And so we are expecting Richard to join us today. He's one who's going to take our session today. Yeah, he was assigned at 3 and 4. So while we are waiting for him, I want to say that I'm not going to be available all through the meet. Yes, I have a lot on my hand. And if I tell you what's going on now, you will not believe. So please, you just bear with me. I will just mute my mic and be on the background. But then I'll be handing the meet over to Blessing. She will be the one who's going to moderate us. So if anything arises and you want to ask anything, you point it to Blessing and then she will address it. She knows everything about the community. And Justice Obasi is here to assist. He's one of our media persons. So he's taking record of the session. Okay, so we could have him after now. So while we're waiting for Richard, I want to give the mic over to Blessing so she could address us, and then we also get to know her, the person who's going to be in charge today. So,
okay, thank you, David.
Blessing, please. Okay.
Yeah, thank you so much, and thanks, guys, for having me. So, yes, I'm really looking forward to this session. I was able to get so much from last session because of the internet. So I hope there are people like me who are also looking and who are eager to learn from Richard. Oh, I'm glad Richard is here. Welcome, Richard.
Okay, good evening, everyone.
Good evening. Welcome. All right, let me just quickly round up, and I'll hand it over to you so that you just continue. Okay?
Okay, no problem.
All right. So I don't know, from the last session, I'd like to know, is there anything you learned from the last session that you'd like to share with us? Or maybe after the session you went studying and then you discovered something that you'd like to share with the house? If there's anybody like that, can you please put your hands up so that you would share with us? Waiting. Nobody has anything to share from last week? Okay, if nobody has anything to share, then I think it would, let's not waste further time. I'd like to hand the mic, the stage, over to Richard. Welcome, Richard. Please carry on.
Okay, please excuse me before he carries on. Since other people are coming in, I want to mention that I'm not going to be around, but I'll be online. Okay, so that I'll be able to admit those who are coming in. So Blessing is in charge of our session today. She's the one who's going to moderate us. So if there's anything, you can point it to a Blessing for tonight. So please, if others are coming in, and you could also address them so that people will know that you are the one around. Okay?
Okay. All right. Thank you.
Okay.
All right. Okay, so you can go ahead.
Okay. Okay. Good evening, everyone. All right. So, in order to explain, based on all I've actually done, I've only completed the mandatory tasks, and aside the advanced. So I will only go through the mandatory tasks. That is, should I say if I should begin from the first tax. Then I will be using what I have already coded to show you through my GitHub, and I will still test run it on my web terminal. So I hope that is okay, because I don't think there is enough time to be able to go through coding everything from scratch. I don't think it's possible, because I've broken everything into functions. I hope that is okay.
Okay, that's fine, Richard. That's
Okay.
fine. As long as
Alright,
you would walk us through it so that we can understand what is going on.
All right. Okay, so I think I will share my screen now. Okay. I hope you can see my screen. Hello? I hope you all can see my screen.
Yes, we can.
All right. Okay.
Sorry, are you using a mobile phone?
Yeah.
It's mobile.
Yes, we can.
I don't use laptop because I do everything on mobile. It's more easier. Oh, you can't see it clear?
I can't see it clear. So tiny.
How am I going to do it? Because this is the only way I can do it.
Okay.
It's clear. It's very clear.
I think it's clear enough. I can see it on this end.
I don't know. If he can zoom it from his own end. You're using the laptop, try zooming it to see if you can get it.
Yes, I think that's the best thing to do.
So, okay, for the first tax here, is actually talking about a beautiful code that passes the Betty check. So, what I would say based on this is, so far the codes that I already have are all Betty check free. I think that one will not be an issue. I don't know whether you understand. So for the second one, which is actually the simple shell, that is totally talking about to display a prompt, wait for the user to type a command line that always ends with a new line. Or should I be explaining this thing one after the other? Let me show you my shell from this end. Yes, this kitchen. Okay, I want to open my share file. All right, I hope you can all see this. Hello? If you can see it, I don't know. I believe everyone is hearing me. So I will be explaining like that. I'll be explaining.
Yes, I can see
that
it.
way. I think you can see a little dot I can use to be pointing. If
yes.
That is okay. All right. So now, based on the question, you can see that in the first question here, we are told to display a prompt and wait for the user to enter a command. A command line will always end with a new line. So I think this part, I will still explain it in that shell. Then the second thing here is that the prompt is displayed again each time a command has been executed. The command line are simple, no semicolons. So all these advanced features are not important in this first stacks. The command line are made only of one word, no argument will be passed to the program. That is very simple and plain. The executable cannot be found. Print an error message and display the prompt again. Handle errors. You have to handle the end of file condition. Okay, so you don't have to do every other thing that is here. So let me break that down. Actually, I've compiled everything all together. So if I'm explaining, I may take cognizance of everything that has been in question in tax 1, in tax 0 to tax 5. But let's begin it gradually. As you can see, this is my string, my shell file. Now you can see this int argc. All these things here are not actually important. Can you hear me? All these argc, char, argv is not important until the last tax. That is tax 6. So it may actually still have a void. You can actually have void here.
Okay, sorry, Mr. Richard. I think someone's mic is on. Can we please put it off so that we can? The echo from it is affecting what.
Okay. All right. So
thank you.
All right. Let me continue. Okay, but before I begin with that main function again, let's take a look at the include files. The include file, I added everything that is needed as possible, including a main.h, which is containing all functions I used in the program. Now, as I said, for the main function, for this first tax, you don't actually need this argc, this argv, and this envp. You don't actually need it. Now, you can see this char string. This char double pointer string. This is actually going to be used to represent an array of pointer. Let me say something here. I think there is a possibility that there are some things that may look new or look confusing. I prefer that you ask me the question immediately you get to spot anyone, so that I have to explain that. So that it will not be that I will explain all through and it will still be confusing. I hope that's okay. Yeah, all right, let me continue.
Yes, it is.
Okay, now,
thank you.
I believe we all know when we see double pointer, this double pointer, what it's actually going to do is, just like this array, let me use an example, just like this char array. This array is going to hold various strings. So that string actually representing.
Hello, Richard. Yeah, sorry to interrupt. I wanted to point something out to the moderator. Someone has been raising hands.
Oh, okay. Sorry. I wasn't paying attention to the.
Okay.
Richard. Hello, Richard.
Yes.
Can you hear me? Can you hear me?
I can hear you.
Hello, Richard. Can you hear me?
Yes, I can hear you.
Okay. Please.
I can hear you now. Or is it for my network?
I think our network is having issues. Can you try to turn your screen? Can you make your screen horizontal, Richard? Can you make the screen horizontal for a clearer view? I think you should try to do that. Try to make it horizontal.
Is it better now?
Yes, perfect.
Yes, it is. Thank you so much.
Very good.
All right. Okay, so as I was speaking, I said I will actually use this my file to explain everything, because you should understand that in order to put all these things all over, it will burn a lot of time. So I just have to explain this way. Okay, I was explaining this char double pointer string. The only reason we have to use double pointer is because we don't want to use an array. Because this array, sometimes it has limitations. So we can easily use this double pointer string because all the attributes, all the elements of this string now are all pointers, because string is actually an address, which is an address having several characters. So that's why you are seeing this double pointer. So all these are I will explain the reason for all this size t. It's just like an integer. These are parameters that we are going to use. Okay. Let's actually skip this at v at c than 1, because it is not for the first task. I don't know if we can understand. Let's keep this. When we get to the last task, I'll get to explain this. But now let's dive straight to this while loop. I don't know if it's clear up to this point. If it's clear, please let somebody let me know. If you have question, you are free to raise up your hand. Okay, let's continue. Now you can see the only reason we are using this ISATI at the start of the program. This ISATI, standard file number. This is actually an idea that Bright brought about, because after I finish everything, without this ISATI standard file number, whenever you pass something like this, let's say, let me show you an example. I hope you can still see the screen. I'm trying to log in. Okay, I want to show you that what I'm actually talking about. Okay, that ISAT now that I was talking about, when you pass something like this echo, I hope you all can see this echo with this string /.
Yes.
If you pass this now, if you did not add that ISAT, showing you that is actually referring to the terminal, is something, that option ISAT standard is the only thing that will make this option, when you pass this to the program, it will actually behave the same way they expect it to behave. When you look at the intranet, the option they show you there, if I should press enter now, you see it actually listed everything and it came out back to the parent environment. I don't know if you get to see it. So if I should show you based on what we have here, you can see now that the same option here, just like what was passed in this, that same option you can see here, it was the same thing that we still get in the results when we actually run the program. So without that option, just know that I don't think if eventually you get any other option that makes it to run that same way, so I think that would be good. But from what I've tested, I don't think I was able to find any other option that works similar. Okay. Okay, that's it for that one. Okay, so let me continue. Now, aside that one, you see the ISAT is only referring to this printf. It's not referring to the entire program. I don't know if you can understand. If you understand, it's referring to this printf. That's why you see it is if ISAT then he has to print this printf. If it is not true, it will actually skip it. I don't know if it's clear. That's for that. Just if it is this, it has to print this. Aside that, then another program is expected to run. Okay, now the next thing after that, you take a note that before you run a shell, what we're trying to do here is that when you print this printf, this thing is only going to show you the C is fun and nothing else. Now, there is going to be a line that a command has to be entered, or let's say a text coming from the input of the keyboard has to be entered. Now, you need to be able to store those things that is going to be typed in an address. And the only easiest way to do it is to do it with malloc. I don't think using an array for it is not possible because you don't know the number of items that can be typed. It's not a particular number of items. So using malloc, we can create a pointer for that. Now you can see this PTR. It was one of the variables we have here. And it is going to have one pointer because it's just a simple address. So we're actually creating a malloc of size n. This n can be any number. So in our case here, we have 20, any positive number. So why I said it can be any number, the reason is that even if we pass it to this getLine, if we call this getLine function and pass this address, and the address of that n, which we have as 20, and we have this, we pass in the standard input, which is the string we are actually trying to get items from. This getLine function will adjust the number of characters. It will also adjust the size of the pointer. So the getLine function is already doing a lot of work for us. So it doesn't matter if the n you create is enough or is not enough. So it can be any number. So far, it is not less than 0. It's better you put either 0 or any number upward. So the getLine will actually adjust it. So that's it in order for us to we will create the pointer so that we can actually be able to pass the address of this pointer into this getLine. This getLine function, what it requires from us is it needs an address of a pointer to an address. That is a pointer to malloc. It needs the address of that. It also needs the address of the number of items that you are planning to pass. So it must not be a number that you know. It may be any number. So why getLine actually returns null, I think. No, okay, it actually returns -1 if it fails, and it returns a positive number. I was saying 0. Why we send in the address of this pointer and this n is because whatever getLine is going to do is going to change things that is concerning this PTR. I need to change things that is concerning this n. So at the end, the value of this PTR will be the value, or will be the characters or what have been typed in the command line. So that's what will happen after this line. What this PTR now will now be the item that was typed on the command line. This n will now be the number of characters that are actually typed on the command line. That's what this n will now be. It most likely will not be the same as this 20. It will actually change. I hope that is clear to this point. I don't know. Can anybody?
Okay, I think Ben Baido was saying something on the chat box. I don't know if he wants to voice out his question.
Please let me voice out because I have to go out from this place in order to see that. Please, can you unmute?
No, I'm just asking. Yeah, that's why I said if he's If he's hearing me, he should unmute and voice out his question.
Yeah, hi. Hello.
Hi, Ben. We can hear you.
Okay.
Yeah, okay, good evening. So I'm
Good
pretty new
evening.
and this is the first time I'm joining. And I wanted to know if there's a prior video to this I can watch. Because I think I'm finding things a bit confusing, honestly.
And this is just the starting point. I think you should be able to. I'm trying to explain it. Is there any place that is confusing? This is actually the starting point. Before we
Because
start
I'm not
going into other questions.
okay, I'm not really understanding the malloc, the ISAT, the standard in all those guys.
No, the ISAT, this standard in file number is just like an indication to show that this is standard. This is like a number. Now. You will have seen this in the last project we did. This standard is something used to recognize the standard input.
Okay.
This ISAT is a function that's used to tell if the command that you are passing is referring to the terminal as the standard input. So there are three streams. It's either the standard input, the standard output, or the standard error. So we are actually concerned with the standard inputs here, so that we know whether we have to print this print F, this C is false. Because if we are not sure that we need to print this if the command passed to it. Can you hear me?
Yeah, I can hear you.
The only reason we apply this ISAT is so that any command that is passed to this program, it has to be, if there is an argument to it, this ISAT will make this printf not to be feasible. It will not show, or it will not execute this printf. It will rather execute every other option and leave this printf. But if the program actually has that standard in, like a command line to be able to take input, then it will print this printf. This C is for. That's for this one, this aspect here. So I don't know if anybody has coded anything and he was able to code it, just like what I explained. If you pass in something like echo inverted echo a string /bin /ls, you pass it, that is supposed to bring out an output. You now pass it with a pipe into this program as if you want to execute it with ./hsh. I performed that test recently. I don't know if we're recording this video, you may likely get to see it. I performed that test so that you will see that it's actually acted the same behavior as what we have in the intranet there. So that's the only reason for this ISAT. It doesn't mean that all this malloc and the rest all will not work, even if it is not there. But it is just for the purpose of that second project, which has that echo pipe, then the execution of the function of the program. So that's just the only reason for it. Then for the malloc, we are only creating malloc. Yeah, it's like you are creating a space. You know, malloc is used to create a memory. This memory is going to hold what you are going to type in the command line. So it's like you are creating a memory to hold what you have not typed. But you just need that memory so that whatever is typed, it will be passed into this memory and saved there. That's what this malloc is actually there for. So it's very important and it has to be there. I don't know if that part is clear. So before, I don't know, are you there? If you are getting that, that's okay. So then the next thing we have there is the get line. This get line function is a function, is a system function that is already there. I think one of the advanced projects is to create that. But in order to use the one that what it requires are 3 parameters. The first parameter is the address of the pointer that you created. So this pointer now, the address of this pointer is what we need to pass into this getLine function. So the next parameter there is the address of this n. What this n means is what number of characters do you think the command line is going to hold? You may put any number there. It doesn't really mean. So far, it is between 0 and above. The getLine function is designed in a way that it will adjust this n to a number that is fitted to any number of characters that is typed in the command line. Then the last parameter there is what means are you expecting to bring these characters into this getLine. So that what we call that is stream, like the stream in which it will come in. So that will now be through the standard in. I don't know, is that clear up to this point? It is clear.
I think it is.
Okay. Okay, so we'll continue. Then this if numchar, one of the things mentioned there in those tags is to handle the errors. So assuming that this get line actually failed, or maybe it didn't work, or something happened, or is it memory problem or so, it will actually return a -1. So but if it worked, it's supposed to return 0, or I think a positive number, depending on the operating system. Okay, that's it. That's just for the error. And before we exit, definitely we are going to free the pointer. If you read more about getLine, you'll be told that even if it failed, you have to free the pointer. So I think you will get to see that if you read about getLine in the using man getLine, you will see it there. So that's why we have to free it, then we now exit. This exit failure, you can still use any of your choice. You already know exit failure is just like a number, more like this standard in file number is a number. So you even if you put 0 here, it's still not a problem. So if you use 0 in place of this exit failure, it's still not a problem. So I hope that is clear. Okay. Now the next thing we have here is this pointer not equal to a new line. Now, before I will explain this, but you will see in one of these tags, I think it's still here. You will see that okay. You see that we're told something here. When an enter is pressed, it still printed this same $sign. I don't know if you can see it. It printed the $sign even after enter was pressed, before this exit was typed. So you see that even if you try it in your shell, whenever you hit the enter button, you will notice that the same prompt is being typed. Like the same prompt comes up. So what we mean by this pointer not equals to new line. Now you see we dereference this pointer here because we want to get the character that pointer is having. Now even if I put this star pointer and put this bracket 0, that's for the first character, to be not equal to this new line. It's still the same thing with putting this star pointer, then not equals to new line. What this means is that we're trying to avoid running this program if only what the getLine function was able to get was a new line. I will come again. Let me go to the shell. So let me try to print this. Okay. So I want to run that program. I want to run the program. Let me show you something. Okay, now you can see this C is fun. If I should hit enter, it still brings back that prompt. Even if I hit it as many times as possible, it still keeps bringing it back. Without putting that, without putting this line here, if this pointer is not equals to this, it's not going to work that way. I don't know if it's clear. I'm trying to explain this before I move into this area. What it means is that if the pointer if it is not equals to this line pointer, then this new line, if it is not equal to it, then you can go ahead and do this. But if it is equal to it, then you need to skip all this and go back and print that prompt. I hope that part is clear. Should I take a little pause and see if there's any question before I go into this? Because we are going into several functions here. I don't know, because is there any question? Or is everything okay like this?
You can continue, sir.
Okay. All right, no problem. Okay. Let's continue. Then the next thing, if assuming it is not equals to this new line, then we have our first item, string. This string, you recall, we have it here. The string is actually a double pointer, which we created this because we wanted to hold an array of strings. Now, note that this array of strings is actually going into the next question, which we are told to handle the arguments. There will not be need for this, assuming we are not going into the next question. So, but you can see now we're actually going to touch it all because there's no other way. It's actually all incubated inside it. I hope that is okay. Or should I show you from the tax? I believe if you have gone through the tax question very well, you see that you are told to handle the argument. So, in order to handle the argument, we need something that we hold each of the arguments. Just like if you type ls, you give space before you type another thing. You cannot type it all together. Now, because anytime you give a space, each of those things are now seen as just like an item. And in order to save those things, it needs to be saved in an array. And that array has to end with a null. That is what they call that null terminated an array of strings. So that's what it means. But for simplicity, we just simply I created this function. You can see this strtok. This strtok is what is actually used to create this array of strings. But this function you are seeing here is not a system command. It's actually something I created in order to make this program small. So the first function we are going to go into now is actually this function in order to see how it works. What this function did was it returned an array of string. That's why this string here is able to hold it. If not, if you actually make this only just one pointer, like if you're assuming you made this only just one star, it will actually show an error when you are trying to compile it. So we have double pointer here because what we are returning is an array of string. So now I will open this function in order for us to continue. That's CHSTM. Okay. All right. So I want to continue. So we can see that our include files, I still use the similar thing I have in other files. I always use the same thing so that I will not start stressing myself with which one is supposed to be there and which one is not supposed to be there. So in any case, if we want to compile, you will be told which one you are missing. So let's continue. Then ignore this line. This line is actually for the getLine function I'm trying to implement. So I did not use it, so you can ignore that line. So now this function, as I said, is going to return an array of string, and is actually going to take the string, because we passed a string into this function from the shell.c. Should I go and open that again?
Hello, Richard. I see you. Okay.
I think it's because I am on call. That's why the network. Okay. So I want to show you what I passed into that function. You can see this PTR so that it will be very clear what I'm explaining here. I'm passing a string, just a string, into this function. This function is not taking in a double pointer. It's only taking a pointer to that string. That's the whole text, what is actually received. This point PTR now is what was received from this getLine. Recall I said that this getLine, whenever it doesn't return anything important, but we are passing these addresses to them because what this getLine will do is to adjust whatever the content of this PTR is having. So just the same thing with this N. So once we are done with this part, this PTR will not look like the usual PTR. It would have already had that content. So that was what to use in checking, testing, in performing this line before we now pass it into this function. So that PTR, we're passing it into this function in order for it to do its work and return an array of string. So that's why you see this line. Before I go back into that function, okay. I hope it's clear. If there's question, let me know, because as I said, there are several functions. If there's any place that is not clear, I prefer to clarify it now. Okay, let's continue. Okay, now you can see that this CHSTROK function, you can see this char star str. What we're actually receiving here now is PTR. We're receiving PTR, which is going to reflect here. We're just using this str as the parameter name. Okay, now we need to create new parameters, which we are still using this. We just created this ARST as the array, as a double pointer, which is going to hold that array of function of pointer, array of strings. So now, first of all, what we are going to do is we need to create a malloc that is going to hold the arguments. Now, well, we need to create a malloc that is going to hold this argument. Now, I'm creating this malloc with I'm using 8 to multiply the size of an array char, because I use size of char star, so that the pointer the size is going to create for this malloc will do look almost like 8 times 8. So it's supposed to be enough. I don't know if this part is clear. Like, what I use here is 8. It's just like 8 multiplied by size of this pointer, which is more like 8 times 8. because the size of a pointer is like 8. So if you look at this, it's just like saying I'm creating a space of 68 bytes, of 64 bytes. So that should be enough to hold enough space for the argument that I'm looking at, because on the normal, the number of arguments we can expect to see most likely may not be more than that. That's why I actually created it with this. This 8, I can still increase it. It depends. Okay, let's done with that one. Then you can see, or should I still explain that? I think it's clear enough. Okay, let me re-explain it, because this ARST is an array, is a double pointer. Why you see this size of char pointer is because of this double pointer that we have here. If assuming we don't have double pointer, we can simply not. I don't know. Does somebody else have a question?
Okay, I'm not very sure I can see the part you're explaining. I don't know if it's my network or I don't know. Because we're talking about double pointers, and I've not been seeing most of the things you've been saying on the screen.
Look at this chart. Boy, are you seeing my screen? This chart.
Yes, I'm thinking mine is probably frozen. I don't know.
I think it's on my end. Yours is still on the first that first file you opened. That's shell.c. Your screen is still on that file. That file that has while loop. The while and the infinite while loop.
You mean that like it's frozen, or should I share my screen?
Like the first file you open, that's where your screen is. That's where your main.
Okay, let me reshare. I don't think I hear you clearly.
What he's trying to say is, it seems your screen has been on that first file you opened, because I've not seen any new file since then.
Okay, let me stop and let me reshare. Let me stop and reshare.
Okay, thank you.
I don't know about now. How is it now?
Okay, this is
Yeah.
This is it.
Okay. All right. Actually, the other part was the shell file, or the shell.c file. Here, I don't know whether you got the part I showed where I was explaining where we called this function. We called this function because we actually passed that pointer that is holding that line, the line we typed something on. We passed that string of the text that was typed into this function, so that it will break it down for us into array of strings. I don't know if it's clear.
Yes, it is.
Okay. So now you will see that here, this char double pointer here now, we are creating a malloc for it. But you will notice that when we are creating the other malloc, we did not add this star here. We included a number which we had as 20 here. But here we added this star. We're adding this star because this is actually a double pointer. So the item is going to have all pointers. So it doesn't need to have this same size as char. It needs to have the size of a pointer. I don't know whether you understand. So that's why we have this size char star, so that it will be the size of a pointer multiplying by 8. So that it's going to have at most 8 strings. So it can be more strings, but for simplicity, I think having up more than 8 strings, it's very rare. So that's why I just indicated this 8 for now. I don't know whether it's clear for this part.
Yes, it is.
Okay. All right. Then after that, we have actually created a malloc for or the array of string. Now, remember that this str here is still a string. You have not broken it down yet. Now, in order to break that string down, you know that when you type that string now is a long text that ended with a new line. When that getLine function picked it, the getLine function picked it and it ended with a new line. It did not have any other thing, more like something that ended with a new line, possibly ending with a null termination after the new line. Now, you can see now we're testing this to know whether it's actually going to return, was able to create this space. If it did not create the space, then we now have to exit. So this is just to control the error. So after that, I think we are familiar with anything to control an error now. It's just, if this actually return a null, we actually come out from this function. And we exit with 1. Okay. So now what follows it is, you see this PARS is still actually a pointer. It's like a pointer. Now, this PARS is a pointer to a string. It can just hold a string. It doesn't need to hold an array of strings. It's just to hold a string for us. Why we are using it to hold a string is because when this strtok function now, we are using this because what strtok function does is that when you call it the first time and you pass in a string to it and you pass in what you want it to look for, then we're passing in a space wherever that there is a space. If you pass something like this, what this strok will do is that the first string it sees, whether it's a string or whether it's just a letter, doesn't mean it will still see that as a string. It will pick that string and gives it to this PARS whenever you call it the first time. Now, how this strtok works is that when it has done this, what it does is this string now is not looking like the ordinary string we already had. It has actually inflated the string that it had that is here because it has placed a null termination in the space that comes after the first string. I don't know how to explain that, but I think, let's say we have, should I use a notepad here or something? Okay, let's say we have LS. Okay, no. Let me use this. Let's say we have /bin LS. And we now have space before we have L. So, let me use this. Now, this space we have here now, is what this strok, it will place a null termination around this point. It will place this null termination. It will place null termination around this LX after it, so that it is returning this string. So what you are going to see this parse having now is this LX. It doesn't have this -L yet. If you call it the second time, when you are calling this strtok the second time, that you want it to get the second string, you need to send in a null into it. Let me show you that. Okay. You can see when we call it the second time here. But before I get to that point, let's go gradually. But for the first one, this parse now is having the first string. That's what this parse is having. Now we need to go through the whole string. So we need to go through it one after the other. So it's looking like a loop. It's like something that when you go the first time, you have to go the second time until the last, whenever I could not find any string and it encounters a null termination. what this STRTOK will now do is it will return a null. I don't know whether if that is clear. If you could not find any other string, it now encounter a null termination. It will return a null. So if it returns a null, then we now know that is the end point. So because of that, we will now say while this parse is not equal to null, so that it will keep going round and round until whenever it is equal to null, we now know that we have to come out from the loop. I don't know if that is clear. Or is there any confusion in that I explained? Let me explain it another way. Any confusion?
It's clear enough. It's clear enough.
Okay. All right. So now, because if that is not equals to null, it goes into this loop. Now, this second while loop here now is to check if this content, we have this j equals to 0 here. Now, what this parse is going to check is if what was entered is a new line. Now, the reason for this is because if actually what was typed has definitely the last content will actually bring back a new line. I don't know if we are clear. Remember that in the get line function, when it returns a string, the last member of that item is actually a new line before the null termination. I don't know if that is clear. So because that last person is a new line, now we are using this second while loop here to check if the this PARLs, the last person that this string brings is a new line. We have to put a null termination there. I don't know if that one is clear.
Okay, the null terminator we are putting, is it before the new line or after the new line?
No, it is the same. We are replacing the new line with that null termination because we don't actually need this new line.
Okay.
We don't actually need the new line. By replacing it with the null termination, let's assume that there is a space. Somebody typed a word. Let's say he's trying to execute something. Then he typed a space and click enter. That enter is a new line. So now, this STRTOK now we still spot this space at the end of that word. Now, when it spots that space, now what it will still bring back in the next string will still be a new line. So in case it gets to see a new line there, it will change that new line to null termination because we don't need the new line. So that this thing is only used to control that behavior. If you did not put this, you may likely not have issue when you did not type a space after you have finished typing. So, but in case you may not know, that space may still cause some headache. So it's better to just put this in order to cover that behavior. I don't know whether it's clear. These are things that may come up. All these are errors I'm able to cover. There may be other ones that are not seen until the checker is released.
Okay.
Okay.
Thank you so much. I think Abdullah Hibolaji is putting his hands up.
Okay. Please, you can go ahead.
Please unmute.
Sorry, there's a mistake. You can go ahead, please.
Oh, okay. Okay. All right. Go ahead. Thank you.
Mm-hmm. So, okay, that's it for that part. Now, you will see that after this second while loop, this iteration we are going to do here is, okay, let's say that's for if it is for that space as I mentioned for that space, if it is only space the person typed and click enter, it will change it to a null termination. Now let's assume that it wasn't a space, it was just a text. I don't know whether you get me. Let's say somebody type LX, normal, just the usual LX. Let's just say LX minus L, or let me remove the L. Somebody just type LS and put enter. Now, if that getLine function works, what the getLine function was able to bring out for us and place in that PTR is LX and the new line. So that new line is a problem. If you pass in that word, LX, and that new line into the execute function, it will not work. That's where there's problem. So what we need to do is to remove that new line that is with that LX. So this second while loop here, the second work it also does is to remove that new line. So now it will check, you can see now, it will check if that first guy, like the first element of the first character of that string, if it's actually a new line. So it's actually going through the whole character to look for new line. Whenever it sees a new line, it changes it to this. And once it has changed it to this, it has actually finished going through it. So this while PARLS J is what it means is that so far this character exists, which is true. It will keep going around the string until it becomes untrue. Now that PARS J, if the number of lengths of that string is 4, and we actually enter J in this J++ now reads 5. So this PRSJ will no longer be true. So this while loop now will now terminate. I don't know whether you get. So that first string, let's assume a first string that it gets. If it sees a new line, it will change that new line to null termination. And so once it has done that, we are now okay that string is now perfect for our use. So after that, this while loop exits. If it doesn't find that new line, it will still exit it. Because if we have several strings, the first string and the second string will not have until the last string. It's only the last string that normally have that new line. So that's it for this second while loop here. That's what it does. So the next we have here is this. You can remember this ARST is pointer to is double pointer, which is supposed to point to an array of strings. So now note that if you say the first element of this double pointer to point to this first string, this I now, you can see that this our I, what it means here is 0. You can see it. So now this note that this J has actually is already messed up. Remember, this J now, let's say if it has checked the first string, is already another number that is not 0. So we can't use this. We have to use something different, which is I, which is still 0. So this double pointer now is now pointing to the first string, which is that pass that we got from this strtok. Because I have not called this function again, so it's still having that first one. So that first string now is having this. We'll now do I++, which is going to change this I to the second string that we're waiting for. I don't know if that is clear. So now, recall that this thing now is about to go the second round. So this our J, we have to reset it back to 0 so that when another string comes, it will start going through it from 0 again. So that's why you see this J is equals to 0. I don't know if that is clear, but I believe. If there's any question, please ask. Okay. Then you can see now at last we now called the PARS equal to strtok. You can see we passed in null, so that what this function does is that whenever it sees null, it as what is passed as this parameter, it knows that it is calling it the second time. So that string, as I said, if you have known how this strtok, we are still going to program this function. How it works is that when you called it the first time, this string that was here, it has actually edited it, that it placed a null after the first string. So we are not concerned about the first string is no longer visible to this strcok. So now, because of this null, it's now seeing the second string. It's no longer seeing that first string. So whenever this is called this way, it will take the second string. If it is called this way again, it will take the third string, because it replaces each string it takes, the space after each string, with a null, so that it can be able to recognize it where it stopped when it comes the next time. So that's how this function works. Whenever it is, in order to program this thing, it will not be an issue once you understand it. So now, if it called, as you have called it the second time, it will now give that value, that string, to this PARS. Now, the value of this PARS has changed. Now, it comes back again to check, does that string that it is having, is it equal to null? If it is not equal to null, it goes through this thing again until it becomes null. I don't know if that is clear. Now, note that this is where we give our parse into this, we pass this string into this ARST. Now, note, if it comes out of this place, we have not passed the last string, which is supposed to be a null termination. And we know that if it comes out, this our I has actually been incremented. So there is no place that when it comes out, it's still having the actual value we need for this I. So we will now simply use ARST is equal to null, so that the last string of this array of string will become a null. So after that, we can now return this array of string. And with that, we are through with this function. Is there any question for this part, this function? No question.
I don't think there's any question. I think you can proceed.
Okay. So let's go to the next. Back to the share. Okay, so back to this share. We can see now that, okay, look at the function. At this point now, you can see that when the array of string is actually returned, this string now is having that array of string that we back. Now, even if it is an argument that was actually passed, let's assume that it was just one argument. This string will still work because it would have done the actual process we want. So even if it is two arguments or two parameters that was actually used in executing this program, it will still work. It doesn't have any issue. So far, this our function worked well. That's the advantage of you breaking this thing down, so you know where the problem is from. Okay. Now, after that, what we are to do now, I think, should I go to that question? Okay. At this point, if assuming we pass the path, okay, LS. Okay, you can see from here what was passed for this first program. This tax 1. You can see that when LS was typed, it showed no such file or directory. Because, okay, I'll still explain that one. Then when this file path was passed, that was when it worked. When this when it was passed with a second something, it did not work because this tax was only meant for this aspect to work. I don't know if that is clear. So what we have actually somehow done more than this tax, but it's still not a problem. This second tax is actually supposed to handle the arguments. That's for this tax too. So what we have done is actually the same thing. So let me go back. Okay, now from our shell, if I should leave all these parts because it is not actually the question, and straight to this, you can see these are all other of our questions, but I will still come back to that. Then let's go to this part where we called the execution. I don't know if you can hear me, so that I will not just jump all the. I want to go the tax gradually. Yeah, this fork ESE. This is where we called the function to execute our command. Now, okay, let me open this fork ESE. If I should click this with this thing. Okay. Okay, these are our execution program. Okay, you can see now that I think from the includes file, all these things is something we're aware of. The reason why I'm passing something like this with this char EMVP, this is because of the environment variable. So you can just ignore that for now. But let me just show you this execution, which we're aware of. If you are executing with EXE CVE, initially I was executing with ESE CVP. ESE CVP can execute even when you type LX without the file part. But this particular one they gave us and they say we must use. You cannot execute with typing LX just like that. You must put in the path. That was why where it was mentioned the other in the question, it was not working with type LX until you the path. I don't know if that's clear. If I should show you again. You can see when this was typed. Okay, this was because of the argument. When ls was typed, no such file or directory because it doesn't work with lx just like that unless you put the file path. Now, that's for this question. Let me show you the number 3 question where they are, what they said. They said fork must not be called if the command doesn't exist. What that means is that I don't know if I'm going too fast or if I'm too fast. If you have question, let me know. I want to explain this shell very well. Okay. That's the third question that said, do not call, you know, when you call this fork ESE function, you have actually called the fork. But they said we should not call it. It should not be called if the what was typed does not exist. So what it means is that anything that is typed must be checked very well that it must work before you call this. That's what it means. So even if somebody should type any jargon string, so far it will not work. There is no need to call this execution so that it will not be like you are wasting your time. So all our checks in order to make sure that anything that is coming into this place, into this fork ESE, must for it to work, we have to do it. That's why you see all these functions between from this place to this point. Now, this first function, this function after this CHSTRTOK, what it does is only just for exit. If you type exit on that command line, it will exit. It doesn't need you to start pressing Ctrl+C. So immediately you press this, what it does here is that if we are comparing this strcmp is supposed to just be strcmp. That's the inbuilt command, but I created my own because the inbuilt one was messing up. So I created mine in order to compare this string and this string. If what this string 0 means is the first string of this array of string, we are putting it into this function to check if they are the same thing. If they are the same thing, it will return a 0. If they are not the same thing, it will not return 0. It will return something like 1. It will return 1. So, but if it is the same thing, it will return 0. So if so, it will break. And whenever it breaks, it has come out from this our while loop. It will now free all these guys and exit. I don't know if that is clear for this exit aspect, because it's still one of the questions. I don't know the question that it was that. That's just to handle it. That was how I handled the exit. I don't know. Is there a question at this point or no question? Okay, I believe everything is still okay. Okay, then this inbuilt command. This IMBT is just a parameter, an integer parameter. IMBT, you can see it here, a number. What it does is that this check inbuilt is a function that check if what the person typed, that is the first string. You can see this string 0 shows the first string. If this first string is an inbuilt command, what inbuilt command means? Inbuilt command is actually different from the system command. Why? Because if you should type which, WHICH, I think, if you type something like this, LOS, if you type this on your command line, you will see a path, something like this. You see something like this. If you type several other commands that you can think of, you may see the path. If you don't see anything like this, and it just display the prompt again, it simply means that is not a system command. And if that command exists, it most likely will be the inbuilt command. So if it's just like an inbuilt command, an example of it is exit. Exit does not exist inside this part. It doesn't exist here. If you type hello, it doesn't exist here. If you type cd, change directory, it doesn't exist here. So such commands are not commands that can actually work using this part. So those are called inbuilt commands. Though it is not part of our question, but it's just here. It can help in case there's a question that is signaling that. I think there's one question talking about change directory. This check inbuilt command will actually you just go into the function and handle anything you want to handle. So that's it for this one. If that first string, if it's actually not an inbuilt command, it will return I think it's a 2 or 1, something like that. Let me see. I think if it is equal to 0, it simply means that it didn't find it. It simply means that that function is not inside it. It's between 0 and 1. Before I'll say that I've forgotten. Okay, so that's to check the inbuilt command. Then the next thing we have here is actually file check. Now let's take note of something. In that question, in the task, we are told to make sure that if the command that was entered, if it does not exist, we don't need to call this fork. Simply, what we are supposed to do whenever something failed is to print something like this. So because of that, whenever that command does not exist, we simply do this. We simply print out this stuff. That's what it means. That is why you see here, if we do this NC is supposed to return the new string. Why is returning a new string? Is there are two things this file check function does. One of what this file check function does is that when you pass a string, the first string into it, if that string is only having LX, if you only type LX, you didn't put the part. This file check will not only check if it exists, it will also append that /bin/ to that LX so that it will be complete. That is why whatever it is going to return after it has done all its checks, and if it is true, it will return a string, and that string we are now calling it NC. You can see this NC is actually a char pointer. That's that. You can see it here. I think. Where did I have it? Okay, look at it here. NC. So that's what this NC is going to do. Then this function is going to take that string. If that string has the part, fine and good. It doesn't have issue. But if it doesn't have the part, it has to append that part to it and now return that string to this NC, which we are now going to use. So we need to now explain this file check, the function of how it's worked. So note what we actually pass to it. We are passing the first string of item to it. So I think that's the case. That is it for that one. Okay. Secondly, this program this file check is only checking the first string. It's not checking the other letters. Let's say we have -L, and what if that letter is not actually valid? What happens? It's not actually checking that, because you can't check that from the file unless it is something you already know. You now start checking it with it one after the other. So, but for here, we are actually checking the first string. I don't know if I'm still communicating.
Yes, you are. Yes, you are.
Okay. Okay, now I'm going into the file check function. So I will explain how that one did its work. Okay, that file check function, what I called it was f.c. Okay, because I initially what I did with it was I created a file, and that file I placed all the files that are inside that bin, that /bin folder. So I later noticed that the functions that was allowed, fopen was not allowed. It was not one of the functions mentioned. So we can only use the functions that was allowed. So that was why I had to change the program, this function entirely. So it is not going to use the functions. These functions are actually mentioned. This open dir and this read dir is actually mentioned in those functions that was allowed. So what this function does from the start is that this dir is like just like you have int, this integer, normal, just, or let's say struct. That is just what it means here. You can see after I mentioned it, you see the pointer to dir here before we now open a directory. What this does is that it opens a directory, and the directory that we are telling it to go and open is the directory that we're passing to it. So if assuming we want to open the current directory, we're just simply going to pass in a dot. So if we're opening any other form of directory, we just pass it here. So what we're telling this dir, this file pointer, is just like a directory pointer, just like we have file pointer. This one now is to open a directory. So it will open this bin/bin/ directory. Now, okay, these 2 pointers now, I was there to still explain how it came about. Definitely we'll see it. Then, for this to work fully, we have to create a struct. And this struct, this drent, you can see it's part of our inclusion here. If you don't include this, you cannot use this drent because they are all together. This struct drent, we created this entity. You see me type here. You can type anything on your choice. It's just like a pointer to this struct. I don't know whether you are getting me. But that is just, let's say, that is just the format of using this open directory procedure. We are trying to check all the files inside this directory to see whether what the person typed, the thing the person typed matches with the name of any of the files inside this directory. That's what we're trying to do here. So now this entity is like a pointer to this struct. Now, if you remember how this pointer to remember how this pointer to struct works. Okay, before we even use that, let's check. We need to check for errors. If the directory will try to open, if it will return a null if it cannot open that directory. That's why you see this control of error. Simply, we don't have time to start typing any place error. We simply return null. So it will just simply not work. It will say that it did not find this directory. So after that checking of error, we now use this pointer, this entity pointer now. What it does is we are trying to read that directory. That's why you see, we have opened it here. We created a struct, something we use just like a name to be able to talk about this directory. Then we now have, we are now trying to read the directory. That's why our entity is equals to read that particular directory. And this dir is actually the pointer. It's just like a pointer to file. That name you gave it. So that's what you're trying to read. That's why you see we passed it inside this read directory. If you just take this context, this is just how you work with directory. Just like the way we work when we're dealing with files. Okay. Now this directory that was read, if it's what this entity does is that it reads each file one after the other. When it gets to the last person, the last file, after the last file, it doesn't see any other file. It will return a null. It does this both for directories and files. What it means is if you are searching in respect to something, either the name of the file or something else, it will search with that respect, whether it is a file or a directory, only what is inside this directory. That's inside this /bin/. Everything inside the /bin/, whether it is a dot, whether it's a dot, whether it is a 5 parts, whatever it is going to go through it all through. Now, okay, that's the case. Okay, now if it gets to the last guy and it doesn't see any other file, it's supposed to return a null. So that null, in order for us to go through the file one after the other, in order for us to go through the file, each file one after the other, we need to use a while loop. That's the only way we can go through each of them till it gets to the last guy. Now, we have this term. What this term is going to help us here for is that it is going to take in the name. Here we see entity. This is the illustration we normally use to get items in a struct, use a pointer to a struct. So we're actually targeting the name. So this the name, it comes under a that falls under this the rent. We will have the name, we have several other items, but we're concerned with the name of the file or a directory. That's why you are using this the name. So if it gets this entity dash greater than sign the name, it will get the name of the first file and gives that name to this temp. In this temp now will now be having the name of the first file. I don't know if that is clear to this point. If you have question, please try and ask if it's confusing. Okay. After that, this temp is having the first name of the first file. Then having the name of the first file. Now, we are not to check. This is that my compare function. What it does is that you are taking this name that you have here. That is what we have here. One of the string. And we're also taking the string we passed. Remember, we passed the first string, which is this str. We're now comparing it. If it is the same, it will return a 0. If it is not the same, it will simply skip this whole part. So let's assume that the first file, it was the same. It will return a 0. And what we are going to do here is that if it returns a 0, remember that the names of all the files inside this /bin/ are names without the parts. Let's say we have LX. What it means is that the LX is without a part. I don't know if that is clear. That LX is without a part. So if assuming somebody type LX, it is not coming with a part. Are we clear? I believe. Okay. If somebody type in LX, the illustration of this function is basically for the ones that comes without a part. If somebody types something like LX, it comes in, it finds the LX. Now, this cat is another pointer, which we have here. Okay. Which we have here. You can see this cat now. Now, what that cat does is, it is equal to, this string cat, this is like concatenating two strings. You are taking this string and this other string. This str is looking like LX. You are now bringing these two things together to become one. That's what this cat is doing. So now at the end, we are going to have this cat having both this part and that string all together. So by so doing, we are going to close the directory before we return. Because we have opened the directory, we need to close it and we return that cat that we have actually append the parts to. So that's why you see this return here. So, but if it is not the same thing, it will leave that part and it will do this again. What this entity is doing again is that it's recalling this function, read directory. Since it's calling it the second time, what this does is that it will go to the next file. So when you call it again, it will go to the next file. When you call it again, it will go to the next file. That's what it will keep doing until it gets to the last file. So whenever it finds the file, then you know that it will do this. If it doesn't find the file at all, and it goes through all this process, then we have to close the directory and we have to return null, which means it didn't find the file. I don't know, for this function, file check, I hope it's clear. Is there any question? No
Right on,
question.
sir. Right on, sir. I don't think there's any question.
All right. Okay, that's it for that one. Then back to the shell. Okay. At this point, you can see this NC is the string that was returned after we have finished with this function. This is our NC now, is the string having that part. Now, what we have to do here, what you see here is that if input is equals to 0, what this 0 means is that if not find it means that the function that you typed was not an input function. That's why it is equals to 0. If it is equal to 1, it simply means that it finds that thing you typed was actually one of an input function. So because it is not equals to any of them, that's why it returns 0. So if input is equals to 0 and NC is not equal to null, what that NC is not equals to null means that, assuming we did not find that file, NC would have become null. But because we find it, NC was actually a string. It's not a null. That's why, because of that, this if statement part will actually run. So our string 0 will actually be changed to NC. So we're now changing this string 0 to NC. So that if we have actually typed LX, that LX that was there will now change to this LX with a path. So it's no longer just LX. So now, since it has changed with LX with a path, now, this other PT you see here, what this does is that, what if what was typed was with a path? I don't know whether you get my point. Because what we checked was if you type only LX. Now, what if you actually typed /bin/LX? Because if you type that, if we do not test this other guy, it simply means that when you type that thing, it will not work. So, because of that, we are using this other function to check the one that has paths. Now, since we now have paths inside what was typed, we have to check. That's where this function will now work. So, now note, if you pass something that has path into this function, this function will actually return a null. That's what it means. This function will return a null if you pass something with a path. So if it returns a null, and this one is 0, definitely it has skipped this part. But it cannot skip this one, because it will still enter here. Now, if it enters this path check, we have to check this function. Note that the string that is passed here is actually what comes out from the get line that has the path with it. I just hope we are all getting it. Or if this is actually recorded so it can be played better. Okay. Okay, now let's go into this path check function. That's all I have here. Okay. Just as we have from the beginning, similar include. If that is placed in the main.h, it's not a problem, but I normally put it. Okay, so you can see that this function is actually going to return an int. That int, what it means is that it will return 0 if it is false. It will return 1 if it is true. That is how I made this function to work. So now, this part that came in, we're now going to check. What we need to do is that we need to test if that part that was typed is actually valid. We cannot test it with the parts. We can only remove the parts and now test. So what we know is that anything that anybody is going to type, it must match this part. If it doesn't match this part, it's simply that it doesn't exist. So the first word, the first thing that the person is supposed to type should be like this, unless it doesn't exist. So now you see that we created a pointer that is having the string and 2 other pointer for reference. Okay, now since the part what we pass was a string, we are actually creating a malloc. The reason for creating this is so that we are going to do our adjustment without stress. Because if you have this and you want to start adjusting, maybe it may not be enough or one other thing. So we created a pointer, a malloc, so that it can at least 50 bytes is enough for any part. So this is just only 5 bytes or so. It does not much, but we just created with 50 bytes. Okay. Now what this does is that if this malloc fails, that's why we have this error control here. Now, if this we are going to iterate like let's say go through this this whole string here. While we are going through this string, what we are doing is that we are placing okay, what we are doing here is that, I don't know if you can hear me, we are going through the first character here, if it matches with the first character of that string that was passed. So now let's say we are starting with I. We are starting with I now, which is 0 here. Now let's say now we are going through this string. So this is the string we are going through. So our concern is to say that this string character should not be equal to the termination, which is the last guy. So that's what we mean by this. No, any other person can still write it their own method, but this is the way I put mine. So this string should not be equal to the non-termination. That should be the end. Now, if CMP I, this I, let's say is 0 now, and this other I is 0. If the first guy of this guy and the first guy of this guy, if it is not the same, we definitely know that what you passed as the part is not valid. So it will not work. And it will definitely print that our error signal. But if the first slash matches with this other one slash, fine, it moves to the next one. I++, it goes to the second one. It checks whether B is still equals to the other one's second character. If it is the same, it goes to the third one, and so on to the last person. If they are all the same, what it means is that it is coming out of this while loop, because at the end it will meet this non-termination, which will make it come out from this while loop. Now note that when it comes out, this I++ is still having a number. Now that number is having a still here. Now we now have to create another loop. This loop we are creating is that every letter that comes after this slash, here this I now will stop when it is equals to this non-termination. So every letter that comes after this slash, we need to pass that letter into the pointer we created, this malloc. We need to pass that letter into that malloc. So the next letter that comes immediately after the slash, you can see now we are using the second string, which is this. And the second string we are using I, which is where this one stopped. So where this one is stopping, like the first letter that comes after that slash. So now we're using this part. If this is not equals to null, then we can go through it. So that's why you see this PTR, P. Why you see P here now? We are using P equals to 0. Why? Because the P has this pointer only has to start from the 0, because we are filling in this pointer to have the remaining parts apart from the slash B, to only have the LX. So we're only filling L to enter the first character of this pointer. So it's not the same thing as what we'll still put here, because this string is supposed to be the I, which is the next character that comes after that slash. So that's why we'll have PTRP is equals to STRI. So once we are going to have P++ and the same thing as I++, so that it will go all over and all over until we hit this null pointer. Now, at the end of this while loop, note that this P would have added a plus, it would have had additional 1 which is targeting to this null pointer. Then we'll now place our null pointer at the end of that string, which has entered this pointer. So these are PTR now will now be equals to null pointer. The end result of this PTR we created will now be only LX, assuming we type /bin/LX. The end result will now be the end result of that pointer will now be LX. So by so doing, okay, sorry. Okay, by so doing, you can see this J. What this J is doing here now is, remember that our 5 pointer that we created, what it checks, it only checks the LX. Now, assuming that we already have LX inside this PTR, we are still calling this 5 check and passing that PTR into it to help us check, after we have removed the part, if does this guy exist inside that place. Now, inside this function, we are still calling another function to check. Now, if this guy returns a null, you can see we free PTR and we returned 1 because it did not find that thing that comes after the pass. But if it finds it, it's simply going to return 0. And because it is returning 0, we know that it exists. So, yeah, we are not returning a string because the string that was passed to this function from the start was having a path. So we don't need to return a string. So we can just return an indication to tell us that this thing actually is true or is actually a false. So that's just it for this function. Is there any question? Any questions?
Okay, based on what you've been explaining so far, right?
Yes.
All the different tasks are kind of intertwined in different files, right?
Yes.
Okay. I just wanted to be sure that I'm getting it right. All right. Thank you.
If it is something to do one task, it is possible to have doing it one after the other. But once you have done all, they will all be all together. So there will not be any way to separate them.
Okay.
So at least what I would say, from what we have covered, I think I've covered almost, is it, how many tasks?
Sorry, please, I have a question.
Okay.
Is it that we're not allowed to use the library functions like stcat, stcomp, stlen, printf?
No, we can use the library, those. There was a place I used the strlen. You can use it. Why I use this strcmp? Why I even created mine? As I said, I don't know. When I compared 2 files, it was like it will be telling me false when it's not supposed to tell me false. So sometimes, when it is annoying you and you are not seeing the program, using this program, I don't know whether you get it. It's like you program something that is not working the way you are expecting it to work. And you feel that you want it to work the way you are expecting it to work. You simply just run and create yours. So if you have the strength to create it, but I believe if something is not working, you have to look for a way to make it work. So that's why some of them I have to create them, but I don't think the only thing I created new that I did not use the input one was this strcmp and the compare function and the concatenation function. Those are the 2 I know I created new. But note that towards the project, I think 2 of the advanced tasks is saying that you see where we have get line, we are going to use our own created get line. That was one of the advanced tasks. Here we use strtok. We are going to use our own created strtok. So you can see now that even at a further project task, you will still need to adjust what actually is. It's not that it will be anything big. when you create the function, you just add it to what you have. So, but for this point, those string function, I don't think they have issue.
Okay. Thank you.
Okay, so at this PT now, you can see when we call this part CHK, well, that will pass this string. If it returns, if it is equal to 1, which is a clue, if it equals to 1, then we are now going to pass the string. Now, this string now, you can see is the array of string. It's not just this fork ESE is a function. I will still open that function that will do our execution. So we're passing the string into it. Why you see this EMVP is because of the environment variable. So the environment variable, there are various points to it. I'll still explain that one, but I think that one have independent explanation. But assuming we don't need it, we are not solving that task. We're only passing this string. So it's because we are not solving with the environment variable. That's why you see this EMVP added as what we are passing to this function. So now let's open this function and see. Take note of what we passed. We passed the array of string. Note, this array of string has a null terminated string. That the last string was a null. So this EMVP, the last string too is a null. But this EMVP, you can see it, we mentioned it from the beginning. So once we have mentioned it here, what it's going to do is that it will take the parent environment into this process. Because when this program runs, it's like a child process. So that environment variable is now passed into this one. So I don't know the actual way they want it to happen, but as it is, all environment variables actually passed into this program based on the fact that we placed this here when it runs. So that's it. I'll still explain that one. But let's go into this fork ESE, the function, so that we'll see how it did our execution. So there's question you can ask. You can see we're coming to the end of this file. Okay, now let's open this one. Okay, so you can see that okay, this function, similar thing, we have our include file, the same thing as I said. So okay, in order to run execution, you already have an idea how it is. We created this child PID, just like using the normal indication, that's the what do they call it? Anything you want to call it. But this is how you create the keyword for it, for this variable. Then this in status is just for our wait function. Okay, now you can see that this is where we are calling the fork. Here, you can see directly we're calling the fork here. Now, this is the child process. Why we're using less than 0? Normally, we're supposed to use -1. But I think because they said some operating system varies, so some may misbehave and return something that is not -1, but a negative number. So that was why you have -0, less than 0, so that it will just print error, fork issue. So you know where the problem is actually from. And what can cause this is when you have reached the highest number of processes. That is when this thing can happen, when it can no longer perform any other fork. I don't know why the resolution of that one. Okay, so if the child process, this is the child process. In the child process is where we need to execute the program, so that after it has executed, it will come back to this parent process. And highest, it will just do this wait, and it will now close this function. So this has to be passed to the child, because normally it will say that once this function runs, this thing will not be printed, because it will not even come back. It will be like something that went into the forest and never returned. So that's what happened here. So it doesn't return. So once this child process see that this guy did not come back again, it will not close. It comes back to the parent. Then for this escape function, now you can see we passed in the array of function. The first guy, that is the first string, which that's why you see the 0. Then we're now passing the full array of strings. Then this EMVP, we're only passing it. Normally, if we put null, the environment variable of what we're going to have as our shell will be empty. If you put null, it will simply mean that it's empty. That null shows that it's just like the last guy of the string. That's why they say this EMVP is null terminated. So if you pass in null, you are simply saying that there's no environment variable. So passing this thing, if you create an array and you number the array, let's say you put several things, anything you want to just type, and those things are in strings with comma. When you pass it to this guy, that's what it will use as its environment variable. But passing this EMVP, since in the main function we still pass it to this function, is going to take that parent environment variable into this our child environment variable. So that's how we run this execution function. I don't think there's any other thing. This is just to execute. That's fine. That's the function. Okay. Is there any question? Okay, now I think we're almost rounding up. Okay, now after we have executed this, now normally it will skip this because you know that the NC was, you know, that if assuming this is not equals to 1, it would have printed this. But if it checks, is NC equals to null? NC was not null. So, and PT, is it equals to 0? PT was not equals to 0. So because all these are not true, any of the, even if one is not true, it will not print this. But if all is not true, it will actually print this. This is just the feedback we are supposed to get if actually this function, this fork process failed. But because we have to perform what they said in the question, that we should not call this fork if we know that it does not exist. That's why instead of this to be called, we will skip this function and print this. So after that, note that we have to free all these guys when we are closing the function. When this thing is even exiting, it has to free all this memory that was actually open. This NC was a pointer, so it has to be freed. The PTR was a malloc, it has to be freed. And this string was an array of string, was a pointer, it has to also be freed. I think if there's any other one that was not captured, it will be seen when it's, I think that V grant something or so, or background. So I think that's it for, okay, that environment variable, if I should explain that, is there any facts I've not spoken of? This, okay, I will still execute program so that you will see how it works, all these things that we have actually done. This number 2, you can see they said handle it with arguments. We will still perform the process. This number 3, they said handle the part. Fork must not be called if the command doesn't exist. We will still handle that one. Now, we see handle the exit built-in that exits the shell. You don't have to handle any arguments to the built-in exit. So we're only handling exits, not something like exit 0 or exit 1, all those things. So now the environment variable, this is only what they showed us. Yeah. But if what this aspect, only this in our environment variable, then we have to pass only these items. Before this equal to sign, you can see, we have to pass only them to the child process. But what I did I've not had the time to reduce it to this. I passed everything. So, but that is for environment variable. Before you now see the advanced tax, which is the get line function and this STTRK. I think. Let me experiment the programs.
Hello, are you still here, Richard? Hello. Okay, I'm not quite sure what's happening, whether the internet took him out or not. Hello, everybody. Let me also be sure that I'm being heard. Can you all hear me?
Yeah, I can hear you.
Okay, awesome. So far, I don't know. Is there anybody who has any questions that you feel like when he comes around, you need to ask? I don't know. If we have any questions, I think it would be nice to put up our hands so that when he comes, I would inform him that we have people who have questions. Hi, Samuel. Do you have questions?
Well, yeah, I didn't really get what he said about his arty function, but I guess
About the
his arty ATTY.
okay.
Yeah, but I guess if it's being recorded, so maybe I'll just watch the playback.
Okay, watch the playback, right? Okay, awesome. Let me see if I can chat him privately and see and get to know what's going on.
All right.
Okay, I'm waiting for feedback from him.
Hello? I don't know when I got disconnected though.
Welcome back. I was trying to reach out.
I don't know when I got disconnected, and I wonder where I stopped before it got disconnected.
Oh, okay. Okay. You said you were going to show us I guess you're going to show us how it works, or you're going to try out some of the functions or something like that.
Okay, I wanted to open. Was it that when I opened the shell, it's like it closed?
I think that was when. Yes, I think that was when it went off.
See that maybe it cannot record on the shell. I did that.
Oh.
But can you see it now? Is it showing now?
No, we can't see your screen.
It's blank.
Yes, it's just a picture of you. We can see.
Wow. Okay, I've not shared the screen.
Okay.
Okay, let me try. I don't know why it is. What about now?
Yes, we can. We can see it now. Even though I wish you would help us turn it the way it was previously. That was a lot clearer. Yes, now this makes sense. Yes. Thank you.
Okay. So I think let me exit, and I don't know that the call ended. Let me clear the screen. Okay. So I wanted to run the program, so I will perform some of the items. Okay. So I wanted to try LX, several of those things. You know, this LX now is without the part. You try it, it worked. You try with the part, that is splitting bin LX. You can still see it worked. Then let's say we want to put the more argument. Let's say let's do LX minus L. You can still see. I hope you can see that the items, how we listed it.
Yes, we can
then,
see it.
The next thing, I think the environment variable. Well, let's see, the environment variable, you can get that through by typing env or print env. So if you type env, you can see. Okay, see that it's actually the whole environment variable from the parent. So it has not been separated yet. Because the one that was shown to us, I think it splitted some and showed only some. So that can still be done. Now, if I want to see the inbuilt function I have is hello. If you type hello, it will now print hello. Then this is host name. If assuming I have the username, it would have just printed my name there. Then if I should type cd, it will still bring the same thing, which is the current directory. So, what else am I to try? So that's just how it works. I don't think there's any issue with it from what I've seen.
Please, can you try the CD minus?
No, the CD minus is not incorporated yet. You know, that one is one of the advanced tags.
Oh, okay.
Yes, it's one of the advanced tags. I've got on that. The only thing I did here, the built-in, that built-in function we have is in that shell.c. When it goes inside, okay, I didn't show you. I didn't show you the inbuilt function, this check inbuilt, how it looks like. Okay, look at how it looks like. It's not like case. Somebody can still use a struct for it. Now, for the first case, you can see why this one that printed it, when I typed hello, you can see what it did. Because I typed get env there, that was why it was able to print that. So when it was cd, if it is exit, the exit was misbehaving, so I didn't even bother to use it. Then this cd now, inside this case one, assuming that you want to create a function for cd. So when you type it, once, if it's just to exchange this CHDIR with the function, so that inside that function, you now do all the whole work of CD. So that's just how it is. This case now is broken down to have the input functions. So that's just what I can say about this shell. So until the checker is released, I will know if there is any other
So
any
you
other
have
adjustment.
that. They ask us to do a hello built-in function because is that one of the tasks?
No. That's hello. That's why I said this inbuilt function. I just kept it. It's still going to be used for the advanced tasks. Which one of the advanced tasks there is to work on the exit and to work on the change directory. So these two functions are actually inbuilt functions that will be worked on in two different tasks of the advanced tasks. I don't think I'm ready for those two. So, but I just why it is just there for that reason.
Oh, okay.
So it's actually for the advanced tasks. Because if it's not for the advanced tasks, it doesn't. It's only the exit function that came in task 4 that I see it relevant. So,
okay.
Based on all we have touched, I don't know. Is there any confusion anywhere? I think, or is it very possible, easy to be able to?
Did you? Sorry, I might be drawing you back. But
no,
did you implement your get line function?
No, I'm still working on the get line. It is still is working, but is misbehaving. So is having some error when you run it with the pipe function. So I have not finished with that.
Oh. Okay. Okay, if you still have time, can you please just go over that? The beginning of your loop, the hardy is Ati. I'm not clear on what that one was doing.
Is Ati. Okay, I didn't run that this thing I see. I don't know whether that's in an existed. Let me see. It has not existed. Let me show you from here. If I exit this. Okay. That is active. Let me show you this function. You can see this. You can see this echo. I don't know if you can see this. This echo / bin LX.
Okay, yeah.
And this pipe will be running function. Now, if I should remove that is happy now, are you getting me? And I run this, it will hang. It will look like it listed the files and it will hang. Or should I perform that? Let me, in order to perform that, I have to edit that function. Okay, let me run this now. Let me run it like this. Can you see it? If I should run it, if I should run this function as it is, now you see that it entered it and it came out. It was able to list the file and it came outside. Now, there was another one that they mentioned. Where 2 items was listed in a file. The ls and the /bin lx was listed in first line and second line in a file. Even if you run that here, it will still work. But if I remove that is hearty. Now, let's say I open that Emacs. Let's say, let me open the shell. No, I will not see it if I use it this way. Let me turn it the other way. Okay. I don't know if it's clear. So I want to remove that is hearty.
Okay.
Okay. Let me remove it with just this. Okay. Okay, let me now run. Let me recompile the file. Okay. Okay, I've recompiled the file now. If I should run that same thing again now, I've removed the his heart thing now. Can you see it? If I should rerun this thing now. Okay, now you can see I rerun it. Look at the end of this. You can see C is formed twice.
I can see what?
You can see I rerun it without that is hearty. You can look at the screen now. You can see that C is formed. You can see it appearing twice before this root at this number.
Yeah. Yeah,
You can see it appearing twice. That's now the problem. It's that behavior now is not acting well because we did not use that isati. If we apply that isati now, you will see that it will not show this. It will just print history and show us this our roots at this. It is like the parents. It will just come back to this parent shell. That's what it will do. It will just print this and come back to this parent shell. So let me go back and remove.
So right now we're in the we're not in the shell, have we? Like right now.
No, we're not in the shell. It just printed this. Instead of it to show us this parent shell, it's still showing us this CIS form. It's not supposed to bring these two items, these two printed CIS form. It's not supposed to do it. So if I should if you check in the intranet, the way it is shown there, you will notice that you will not see something like this. Now, if I should go back now and remove those things, I remove and add back that is hearty, you will see that everything will come back to normal. Okay. Okay, now so let's compile back. Okay, so now if I should run this same thing now, you can see it came out once. It didn't have to print that C is phone again. You can see it.
Oh, okay.
You can see the function. The only reason why we apply that is that. So that's just its work.
Does it have to do with the interactive mode and non-interactive mode? Is this it? In the
yes. That's just it now. In the interactive mode, they showed something there. In that interactive mode, from this question. Okay, you can see this text file now that is here. This text LIS. Now inside it, two things was typed. That's why they type cat so that it will list what was there, so that one can see it. Now with that cat, they now run it together. You can see cat test together with this. Okay, if we are to perform this same thing now, we need to type these two things inside this file and run this and see whether it will print. It's supposed to list the content of this file twice, because it would get the first line and get the second line. So it is like it's running two things at once. But I have to try this now. if I try this particular one, what we need to do is we need to click the file that will have these two contents. And note, when they click cat, this last item has a new line. That's why it was able to print it. That's why this $sign came out here. It didn't come out at the end in here. It came out after the second line. So let's create a file just like that. So now if I should create that file, okay, let me just say Emacs. Let me just type Emacs. Okay, let me type those two things. /bin ls and another /bin ls. That's two things. I entered into the user. Okay, now. So in order to run that same thing, I need to do, if I should do cat E, this cat E is supposed to itemize those things. Now I'm passing it with a pipe. With this pipe, now I'm passing it to ./hsh. Now, this now printed the files twice and it came out. You can see it. You can see it printed it twice. You can see how it printed it, just like we have there, without any stress. So if we do not use that ISAT now, it will not work this way.
It won't print it out sometimes.
No, that ISAT, it will have misbehavior now because that C's form will come out. It will not look exactly like what we have, which is already an error. I know ISAT is one of the functions that was said to be used. So since it is there, if you don't use it here, I don't know where again you will most likely use it.
Thank you. I didn't know I hadn't even used it at all in my own.
Yeah, that is I don't know if you have done your own and it does this behavior without you using it. I think you now have to share what you did because I did everything I can. It didn't work.
I've never run this test on my own. And I've not done. I was
okay.
I haven't done
you try it. You see. Okay. Any other question? Any other question?
I noticed that in your what did you call that file again? Was it file check or something like that? Where you like where you used where you read the directory, open the directory and read the directory.
Yes.
In that file, I noticed that you only specify like one direct /bin/. So that means if the program that you want to run is actually not in /bin/, that means your code won't work. Is that correct?
Yes. If the program is not inside that /bin/, it will not work.
Okay, well, there are some programs that are also in like /bin/sbin /user/bin. There are some other directories that hold binary files.
If there is, let's say now, okay, let me open this one. Let's say I want to run. Even if I should run this my file, I want to run it and open it inside it again. I doubt it will work. You can see it didn't work because I didn't capture it. Why we didn't place it to work is because they said if it does not exist, then it will not work. So in order for somebody to say he wants to search it if it exists, you have to search through the entire files he has in that shell to check whether it exists. So you now know that if you are going to do that file check folder, that's why I say the checker has not been released, which I cannot tell. So simply, if it is released and it requires that it needs something like that, you now have to go through the entire file, entire directory of the whole shell to look for that.
All directories in parts.
Yes, all of them. So you already know this thing that can do that is something that you have to take that time and now capture, which I would have just said is because they said if it is not one of these things, then you should not call the fork. So if you are not to go through the whole files in the entire shell, and then somebody has a lot of program there to write.
Not really sure. It's because of the way you did it. There's the way you can capture everything with 10 lines of code.
When you open that directory, it will list a directory. So what it simply means, if it sees a directory, it still needs to open that directory to search. So it will open from the first slash. The first slash has to be listed. Any directory it encounters, it needs to. I think there's something you can use to open all directory. That it will open something that will list all files in the entire shell when you click slash. So I cannot remember what is going to be used to list that. There's something that can list all files at once, whether it is inside the directory or so. So that one can be used. If actually that is pointed that I cannot see, I'm just waiting for the checker. If the checker says that it has to be done, then it has to be done.
Because what I did was I got parts, all the directories in parts. Then I used Tetalk to separate each one. They are delimited by a colon. Then I put them in an array. And so I go through the array each time, concatenating my ls or whatever command onto each one. Then I use access to check if the file exists. If it exists, then it will return it to me. Then I'll use it to call the command. If not, it will just return null, and I won't call the command. So I was able to use all the directories in parts like that. And it was, I don't know if there are any more directories that they will check. And that's where
his access is also one of the functions that can be used. So that is another one.
Yeah.
I think you have not used that.
And that one was more, I think it's more dynamic.
It can be incorporated now. As I have this now, after it can be added as another option before the error signal will come up. So that it will check. So it can still be added. So aside that, I don't know. If there are any questions again, let me know. That will just round up.
Okay, thank you so much, Richard. Do we have more questions?
Is there going to be any other session, like maybe tomorrow? Or...
I would have to confirm with David about that. Yeah, you want to say something, Richard?
It's until that tomorrow now. Then when you confirm from me, because I cannot see any other thing that is there is that get line function, the STTRK function, so on. So
okay. Okay, so we'll confirm from him and know if there will be if any class will be scheduled for tomorrow. Then he'll send a link to the group. What do you all think?
Okay.
Yeah, sounds good.
Okay, all right, awesome. Thank you so much, Richard. This has been this is amazing. Wow, I didn't know we had serious I didn't know we have awesome hands like this on this group, and I must say it has been an interesting session. and I shall be in your DM. You know, I can't see someone so good and not to be in their DM. So I'm going to be in your DM definitely. And Samuel, thank you so much for asking all your questions. I think your questions also helped expose some areas that some people had questions but probably were not ready to ask. So thank you so much for all of the questions. And yeah, it was an awesome session, and it's actually late, so I would say we all unmute our mics and say good night to each other and have a lovely night rest. Can we just do that?
Good night, engineers. Sleep well.
Good night.
Good night,
Good night.
everyone. Good night.
Good night. Have a lovely night rest.
Yeah, good night.